Okay, thanks for coming out for I guess, probably the last session of the day. Let's get started. My name's T.R. Bosworth. I'm the, is this too loud or? Okay, so I'm T.R. Bosworth. I'm one of the product managers for SUSE OpenStack Cloud. Room Kent is one of our lead engineers on the containerization squad. And so what we're going to talk about is the containerization tech preview that we're bringing out in May. I'm going to introduce kind of why we're doing this and kind of what it looks like at a high level. And then Arun's going to get into all the details. We've got some recorded demos, so you actually get to see what it looks like. And we're going to do like 3 different use cases of actually using Airship to deploy OpenStack containerized on top of Kubernetes. So it's kind of cool stuff. I think you'll like the presentation. So this is the agenda. Like I said, I'm going to kind of talk about why we're doing containerization, then a bit about the Airship project. Then we'll talk about the tech preview, and then I'll turn it over for all the real meat of the discussion to Arun. So I'm just going to talk about fluff, and he's going to tell you all the details. So why are we doing this? So first off, what is it? If you think about any application, you can pretty much containerize any application. So OpenStack is an application, and typically it's laid down on bare metal with a control plane and a compute plane and storage, et cetera. So what we're going to do is we're going to actually lay down the OpenStack services as containers on top of Kubernetes. Of course, we're going to use our Kubernetes distribution, Container as a Service platform. And one of the things that we're actually leveraging is an upstream project called Airship. And I'll kind of give a little bit of an introduction to that in case people aren't familiar with it. But this is a substantial change in our approach to lifecycle management, that we're going to be using a new method that's more upstream oriented to do lifecycle management. And we're bringing out this tech preview around the Cloud 9 timeframe, but we're targeting to make this the base for Cloud 10. So part of this tech preview is all the people in this room or anyone that's interested, we want you to have a look at it and give us feedback. So whether you're a partner or a customer, internal SUSE people, everybody, we would like to have good feedback. So, this is kind of a few of the reasons why we're introducing it. Upgrades have typically been kind of hard in OpenStack. With using containers, you have the ability to upgrade individual components easier. You also have an easier method to scale up and scale down things in your control plane and your compute plane. So those are a couple of the major reasons. As a result of switching to containerization and using Kubernetes, we're actually going to be leveraging some of the built-in HA that Kubernetes provides. So right now we ship Pacemaker and we configure HA in our control plane and different components. We're going to be actually leveraging the underlying technology in the Kubernetes orchestration to do that for us. So it's a bit different. So let's get into the more information. Here's the tech preview. It's starting in May. This link for the cloud beta for Cloud 9 actually will have the information of how you pull that down when it's available in May. So I've kind of covered some of these things. I mean, this is really an important milestone for our Cloud 10 roadmap, so that we get good feedback, so that we do things right the first time when we get to Cloud 10. So in case you don't know what Airship is, Airship is an upstream project that really starts with a whole bunch of cloud or definitions. So these YAML files on the far left kind of say what you want to do. And they end up generating a whole bunch of things about how you're going to use the bare metal, security policies, networks. And there's a bunch of Helm charts that kind of define how things are going to be deployed in a Kubernetes configuration. So you basically, there's a whole bunch of sub-projects within Shipyard, and Arun will kind of talk about which ones we're actually using. But you submit these parameters to Airship, and then it deploys the cloud. or deploys really any application. It doesn't necessarily have to be a cloud. The way it's built, conceptually, you could define something that you want to deploy on Kubernetes, and you could have Airship deploy anything. But right now it was purpose-built to do OpenStack, but we're actually looking at it potentially for other SUSE things in the future that may fit into this model. So this is just the overall kind of picture conceptually what's going on. So the idea is that we would have some sort of a deployer that will probably be built on SUSE Manager. And we would package up the Airship components within that distribution so that you would install a SUSE Manager, and then from that point on, you would have a guided install that it would actually down the CaaS Kubernetes cluster, build all the nodes, and then Airship actually has all the smarts to label the nodes correctly as the type of node it is, whether it's a controller or compute, and then deploy using the Helm charts in a repo the proper components onto this Kubernetes cluster. So you can see, Keystone Swift, your normal OpenStack services at the top being deployed, and when it's done, you would just operate at least your OpenStack layer with the same way that you did it before. The APIs, the Horizon interface, everything would be the same. It would just be containerized, and underneath we'll be using all the services of Kubernetes to do some of the HA and different things. So one of the powerful things is when you see the demo is the ability to kind of change things quickly, then redeploy, and the different containers get fired up as you make the changes. So as I spoke about before, we have 2 lifecycle managers now. We're going to provide an upgrade from 8 to 9 for Crowbar and 8 to 9 for CLM. And this tech preview is really off on its own island. We're trying to make sure that we get good feedback before we go to Cloud 10, and we're going to provide a mechanism to go from Cloud 9 to Cloud 10 for both lifecycle managers. At the end of the day, when we get to Cloud 10, there's only going to be one lifecycle manager, and it's going to be based on Airship. So one of the things that we're working with in the community is to potentially build the UI for Airship that doesn't have an Airship UI right now. And so we're going to be working on that. So that is really my part of it. So Arun, take over.
Okay, so let's talk about this slide, right? So right now, this is Airship is a upstream project which has a lot of components and basically related projects in the upstream. And those sub-projects are primarily related to the different life cycle aspects. So like if you want to do a bare metal provisioning, so there is a separate project for that, which is DryDoc. And if you want to do a cluster management, then there is a separate project, which is Promenade. So there are different components and projects in upstream for these different life cycle aspects. So in this tech preview, actually, what we are focusing on only the subcomponents or components basically which are primarily used for our use case, which is the customer will already have a CaaS cluster deployed, and they will already have a SES storage configured. And what they need to bring in is so in that case, actually, what we are saying there is no bare metal provisioning involved, and also the SES configuration is already there. So in that case, what we are looking into is we have looked into and actually we are using this in the tech preview also, the Armada, Shipyard, Backend, and Pegleg. These are the Airship components. And then actually in upstream also there are projects called for OSH, which is OpenStack Helm, and which provides the Helm charts for different OpenStack services. And then there is an infra component basically which are like core components, MariaDB, RabbitMQ, Prometheus, and all. And so we are leveraging all those projects in addition to the Airship components. And those, so like we can talk about like Armada is more like a management tool for managing multiple Helm charts, and way of basically defining the dependencies across multiple charts. It also provides the keystone based authentication for undercloud, I'm going to basically explain what is undercloud is. And then it also provides some kind of what you call lifecycle hooks for the Helm releases. So Helm is actually, it's a standard package repository, package management tool for Kubernetes. And it's, I mean, essentially, if you think of it, it's a collection of files for defining the Kubernetes resources. And then basically that collection makes a one particular release. And what else? So Armada is primarily for management of the Helm charts. And then Shipyard is something which is used for, it has a component called, what do you call the workflow engine. So it has a workflow engine. So whenever we get a site, and then there are, site is basically a manifest which has a bunch of, what do you call, the YAML descriptive, declarative representation of the various Kubernetes resources or Helm charts. And so Shipyard is a basically a CLI based, and there is a CLI component and the server component, and it provides various actions which maps to a workflow, and then workflow has multiple steps. So let's say if you are deploying one particular site, so that particular site deployment may have steps like which is validating the user input or the site information, and then basically storing the revision of that. So basically it has a backend which is what do you call a document based configuration storage system, and it also provides you the versioning of the documents. So whatever the configuration you are providing, the customer is providing. So it basically creates a versioning information so that if the customer wants to roll back, actually they can roll back. And then then there is a PagLag, basically, which is more like an offline tool, and it is primarily used for linting the various customer or what you call the site manifest, and it basically collects it together in one particular file and then provides it to Shipyard as an action. So Shipyard will say basically once the site is there, create this site, and then Shipyard will post that information first to the backend for storage, and then backend will do the validation. Once the validation is done, then it will start the workflow. And the workflow, for the workflow we are using, means upstream is using Airflow, which is an Apache project, and so this is, then it's converted into various actions. And all of the information about the site is entirely a YAML documents, and it's declarative. And so let's say if you want to define your bare metal nodes, right now we are not doing this, but I mean it's still there. Its support is there in upstream. If you want to provide the bare metal node, so you can provide a site topology in the YAML manifest, and then actually that will be used by DryDoc to basically configure the to your bare metal servers. So in upstream also, right now we have made substantial changes in adding the multiple distribution support. So we are changing charts where means right now it's catered to one operating system. We are adding support for multiple distributions, and so OpenSUSE is one of the distribution we are adding support for that. And then also we have changes made in the upstream projects primarily in the image building area, where we are adding support for SUSE images. So because all these components and all the services we have, like Glance, Nova, and the Keystone, all these are basically distributed as a image file. So right now, so we have added support for Rocky version, and then at least Leaf15 based images. And on this node, on this slide actually, so the customer has to do is basically they will have a one node basically which is catered toward for building and deploying. So this could be a customer laptop, or this could be it just needs to be a SUSE-based node. It could be VM also, and then actually this is SUSECON Kubernetes is our code base, which is actually it's in open source. But so this is something which has Ansible-based playbooks, which configures the basically which uses Airship CLIs for various components, and then actually it configures the undercloud and then overcloud. So let's go back to that. So undercloud is, so all these for Airship deployment, so there is two major namespaces we are using it. One is undercloud, which is for deploying the Airship components. So for the Airship components, we have Armada, Shipyard, and all these components are deployed in undercloud. So when we say undercloud, it's more like in Kubernetes world, it's a namespace. So we are grouping resources in that particular namespace. So it's called UCP. And then actually we have overcloud, which is actually the OpenStack deployment. And in that OpenStack deployment, we have all the services. Right now in the tech preview, actually we are supporting the Rocky images, so Rocky version. And most of the core services are going to be there, and also for the containerized compute part. So right now in tech preview, actually what we are delivering is containerized compute. So what we are saying is for the libvirt and the OVS and all that, those are going to be deployed as a pod, and the SUSE enterprise storage actually just means we need actually we are using it for storing the compute related data, and also for the undercloud. So means for undercloud actually there is a means we are for maintaining the state actually for the backend actually we need a means in addition to MariaDB actually we need another database. So that's also stored there, and it also provides the keystone-based authentication, and then actually for secret management with like passwords and all, it can use Barbican as a key store. So in the undercloud, actually there is an option of using Barbican as a for the key management, for storing the keys and the certificate you have. So let's go to the next one.
You want the clicker?
Let's go. Okay. So this is okay. Yeah. Right. So this is again actually what we are talking about is the customer will already have. So what we have for the tech preview actually we have tested with CaaS version 3 and SES version 5, and so again it means we are using the upstream project site manifest is actually what we are talking about is the site which is also an upstream project for Treasure Map, which provides the reference implementation for Airship. So there are like two different reference implementation available. One is Airship in bottle, and then which is like means if you want to do a bare minimum Airship deployment. And then also there is this another called Seaworthy, which is more like a production deployment. And so we have the similar manifest file, and actually we in our code base, and actually we have done some overrides and optimization based on basically what we think is better for the customer, and actually it has some defaults which are some defaults are different from the upstream because of the version of images we are using. Upstream supports Pike, OpenStack Pike release for the OpenStack services, but we are going to support the Rocky based release. And okay, so I think let's go to the next one. So this is again, yeah, so what the value of Airship is actually, it's more about it's all the Kubernetes resources are represented in YAML means it's all the representation is in the YAML documents, and it's declarative, and once you have a working site, then actually you can use the same site in deploying in different clusters also in different regions if you want to. And also Airship provides I think I mentioned about that, like actually it provides the management of the multiple Helm charts. So when I say, so that means when you, so there is a concept of overrides in Helm. So means you have one particular service and then you want to define like how the RabbitMQ, where the RabbitMQ pods are and what's the connection information or the credentials are. So that information is basically specified in each Helm chart in the values and all that. So in the Airship, actually, the way it is managed is very nicely. So that means you define once, and then you can reuse the value in different places. So it provides the flexibility of declarative means usage and also reusability across multiple services. And so those are overrides. So basically, what we call it simplified overrides. And actually, we already have when we provide the site manifest information. So we already provide the defaults for the customer and optimize defaults, and the customer may not have to modify most of the things. And
so one thing I'd like to add is this is more on the CLM model. If you're familiar with what we do with Cloud 8 and Cloud 9 with the Cloud Lifecycle Manager, it's kind of defining something up front with the parameter file and then being able to repeatedly do that over and over. So that's very important. The other thing is we're going to try to keep some of the complexity of these YAML files kind of in the background, where if you're doing normal things, you define your network and storage and stuff with the site manifests, and you may not have to actually know everything about Airship. So that we're going to try to make it kind of simple to get started, but you have full control on the back end. If you really had something that you wanted to do that was different, special, whatever, you would have complete control on the back, but we want to try to make it pretty easy to get going with this.
So yes, so let's go to the next one. So okay, so let's start the demo first. So I want to show the demo, and actually it's a recorded demo. So in this demo, actually in the initial step, actually I'm going to talk about the initial setup. So what kind of setup is required, or means we are asking for the customers to do. So we are using Ansible for orchestration of all the deployments. So the customer has to provide the inventory information about the nodes in the CaaS cluster, which are basically and they need to identify basically where do we want to install the UCP pods, where do we want to install the compute pods, OpenStack compute pods, and where we want to install the OpenStack control plane pods. So they need to identify which node they want to use that. So that's basically the information they need to provide. And so they need to provide the host groups for different purpose. And once that information is there, and this is so right now in this demo, actually I'm using 4 worker nodes, and out of the 4 worker nodes means there are 2 nodes which I am primarily using for OpenStack compute nodes. So where the customer will employ so this is what we are showing. Oh, okay. So this is what is actually in the information. So from the CaaS, so this is the Valum interface for the CaaS, and actually, so what we are showing is this is the already existing cluster the customer has, and actually they already provision 5 nodes, 5 worker nodes, and then there is a master node also. And so this is the same information what we have captured in the inventory file. And then also there is a additional information what the customer has to provide is like what are the FQDN for the external WIP, and what is the FQDN for what is the IP address for the external WIP and also for the management WIP. So this is something they have to provide. And so this is the configuration file which the customer will have to modify. And so right now, so these are the external, and DCM is the management WIP, and then actually there is a scale profile which I'm going to talk later, And then also we are using the admin key, which is used by Helm charts for configuring certain pools in the Ceph storage. And
can you use a storage class instead of a direct access to the storage?
so we are using, you are talking about the Kubernetes storage class, right?
Well, yeah.
Yeah, so yeah, actually, so internally, actually, it maps to the, on the Kubernetes side, actually, it creates a storage class resource. It's just, we are just using the keys.
Yeah, because when you use the keys, you're actually talking directly to the storage versus going through the storage class. But
Okay, okay. So are you talking about the storage class on the SES side?
Yeah.
Okay, I think, yeah, okay. Maybe I have to look, we have to look into that, actually, yeah.
Okay.
So this is, so these are the two areas basically the customer has to provide the information. And so this is what we are, okay, so this is a Airship way of defining the site. And this is the directory structure means the Airship, upstream Airship also provides. And in the tech preview, it means we are focusing in the secrets and software area. So this secret means name says actually it's mainly for managing the passwords and certificates you will use for under cloud as well as for over cloud. And then in the software area means there is a manifest file which is for defining what Helm charts or Helm chart groups you want to use for UCP and for the over cloud. And then config file is basically around what version you are using. So in the Airship actually it provides each component level, what component basically, what kind of release you want to use. So means for certain, means like if you want, means there is a flexibility there. Actually, if you want, you can use for Glance API, pod, actually you can use one particular release, and for the other component of Glance, means Glance registry, you can use another version. Means there is a flexibility, but actually you don't want, it doesn't make sense, but there is a flexibility means you can use per each pod what kind of component or what kind of code base you or the release you want to use. And the way basically it does is on the git SHA for that particular repository. And so the profiles, and this is something basically which is primarily used for bare metal provisioning. So if you have a declarative site topology, then actually you can define there, and then actually based on, and I think it asks you for the network information and the bond information and all that. And so let's move on. So this is like, so we are talking about the full site. So this is what we are talking about, the over cloud. So this is the OpenStack deployment, and it's in the OpenStack namespace. So these are the components, or these are chart groups we are deploying. And so this is an ingress controller for the VIP. So each namespace has its own ingress controller, and then MariaDB for database and all that. So, and I think there is another, means the compute kit is defining, so it's a chart group which defines neutron service and as well as Nova service. And so those are defined as chart groups. And that's a basically way of defining the dependencies between different Helm charts. And so then actually, I mean, so all these are different references. And one of the nice thing about Airship is actually it provides the, so for the site authoring, so there is a concept of layering. So layering means inheritance. So you can define a global site definition, and then you can have a type definition, basically, which can be region or anything like that. And so you can define the base default, then you can define the site level overrides. So if you want to change something in particular site, so you can define the site level overrides. And so there is a concept of inheritance, so layering. And then also there is a substitution, basically, where you can change the values. So this is the manifest for the overcloud. And so similarly, there is a manifest for undercloud, actually, which primarily mentions the Airship components. So this is manifest for the Airship components. Actually, it's similar. So it has Keystone, Shipyard, Deckhands, and Armada. And after that, actually, so this is the initial setup. Now, for the deploying the Airship, actually, so what we have is right now we have a CLI based. So we just run a CLI, which is part of our code base and on Kubernetes, and we just say deploy Airship, and it's gonna do all the So essentially, it creates sub volumes in the CaaS clusters because we need a read-write permissions on certain directories, some directory mounts actually, and so this is actually, we are just going through the. So this this is the dashboard actually which comes from Kubernetes. So actually, we are leveraging that right now for displaying what kind of pods are there in the kube system namespace, which is a Kubernetes namespace. So these are different pods, and actually it provides you a nice interface of viewing what are the resources available, and it also allows you to make edits in that. So right now we are in the kube system namespace, and then actually these are the pods there, and behind the scene actually it's trying to do the development or deployment. So it looks like, yeah, so the UCP namespace is already created, and actually it has already deployed the Armada pod. Now actually what it does is it copies the manifest file for Armada components, and it's gonna start deploying that. So it's trying to deploy the UCP pods through Armada API, and so let's move forward. So Armada API pod is actually the pod which actually provides the interface for site management. So when we say site create or site update, so site is something basically which is the whole complete manifest for over cloud and also for under cloud. Actually, we are using for both. And it means Armada API pod is basically the interface which does all those operation, and it passes to Shipyard, and then actually it does the basically it passes to the workflow engine and all that. So right now, so it looks like so now we already have a OpenStack OSH namespace pods are coming up. So this is where basically all the services are coming up, and so generally this deployment means from start to finish takes like around 20 to 30 minutes, and but there are areas basically we can improve on, and we have to look. We are looking into that, and so once this deployment is there, then actually we will see. So so now we have these services. API pods are already there, and actually so these services are already deployed, and so that's the deploy Airship part. And so now actually what we're going to do is actually we're going to cover 3 different use cases, and which I think can be useful to see actually. So come on, so this is actually the deployment has done, and actually it goes through the various actions and steps. Okay. So this is one common use case basically. So right now when we deployed the Airship, so we deploy the minimal scale profile. So what does mean is that actually for all the pods in the UCP, actually we only deployed one pod for each functionality. For Shipyard, basically there is only one pod, and then for all backend also basically we have only one pod. And similarly on the OSH, basically which is an overcloud, we also deployed one pod for APIs also, but that may not, that's okay for means for the dev or basically for simple POC, and or maybe with but if you want to do a what do you call more like a production like an setup, so in that case you can, so we have provide the configuration on our side actually, where we are means making those changes in upstream also. We are providing the concept of scale profiles in the Airship, and So there actually what we have to do is actually, so there is a configuration file we expect for customer to modify, and so this is an extra var, and actually there's parameter we have. So here actually, so we already say by default means it's a minimal profile. Now what we're going to do is change it to HA profile, and then actually we go to the same CLI interface and we do the update Airship OpenStack Helm. So update Airship OSH, and so what it is going to do is now actually it will regenerate the, so it will do the linting of the site manifest and then do some basic validation, and then after that it will pass to the shipyard, and then shipyard will pass it to the backend, and actually it will do certain diff operations and try to find out what is changed, and then based on that actually it will create the updated Helm releases for those services which are changed, and then actually it will create the updated what you call Kubernetes specs for different pods, and so now actually because we have an HA, so now we are going to see the MariaDBs. Earlier it was only one pod. Now actually there are 3 pods are coming up, and again it's going through the initial basically initialization of all these pods, and and the customer has means like right now we have predefined this 2 profiles, but the customer has an option of basically defining their own profile. If they want to change, if they don't want 3 pods or they want more pods, actually they can change, they can create their own profile, and then actually they can, means we will provide the instruction actually how to use that profile, and so I think this could be a means, so it's just a means from the customer point of view, actually it's just a minimal change on the configuration side, and then actually it's the same user experience, means it's the same CLI actually we are using for deploying as well as for making changes. So let's go to the next one. I think what's the time? So this is the Keystone API pod. Okay, I think so second use case is, so this is the use case where what we are trying to do is expanding the compute capacity. So right now as I mentioned, actually we already have so for expanding the compute capacity, actually, so what is the requirement is actually the additional node actually the customer wants to add, it needs to be part of the CaaS cluster, because right now the compute is containerized. So we expect that actually whatever the new node is, actually it's going to be part of that CaaS cluster. I think in cloud, and actually we will have bare metal also for the compute, but right now what we are doing is only for the basically containerized compute. So I think so in that case actually what we are doing is actually we are changing the inventory file, we are adding the new node which is already part of the CaaS cluster, and so that's actually what is being done in this file. And actually so right now we are adding a new node which is already and this is, and I think we're going to show, so this is the hypervisor we already have. So these are the 4 compute nodes we already have, and then actually those are mapping to what we have in the initial deployment. So what we're going to do is actually we're going to comment out this new node, and then actually it goes through this, and then actually we have the same. It's just a different target, but it's the same Ansible playbook we are using, and it goes through the same workflow, and it basically for actually, I think I noticed I think a couple of days ago actually we don't need to go through the whole interface for add compute, because the way that works, it's for adding compute in the Kubernetes world basically is we just need to add labels, and once the labels is that, actually we don't need to do anything. So we don't need to create the site manifest in this case, because Kubernetes is going to take care of that. So once you add the label for this particular new node, it will see, oh, there is a new node actually, so now I have to deploy the related pods. So basically it's going to deploy the OVS, it's going to deploy the Nova Compute and libvirt. So it looks like it's already done that. So I'm going to skip this and
So just to confirm, all these operations just go to the site manifest, you make some changes or are overrides, and then you run the same process and it regenerates all the changes in the cloud. Is that right?
Yeah. And for the compute, actually, yeah, means we don't even need to do the regeneration of site manifest or basically the linting and all that process, because the way the Kubernetes works means it just means if you add the label, actually it will identify, oh, this new pod requires these, because the way the Helm charts are defined, basically they already have the labels, the pod selector. So that way, so now this is the third use case, which is interesting actually. So right now, so far till Cloud 9, so whenever we deploy services, actually we need to make sure that all the dependencies, so if you're deploying Nova, so basically if Nova requires certain RPMs or libraries, basically which is shared between different services, because it's deployed in the same VM, so you have to make sure that actually it's compatible, right? So the versions are same versions for everything. And but in the container world, actually, because all these services, all these components are deployed in a pod, so there is isolation available to us. So actually, if you want, you can deploy Nova API in one particular release and another component in another release, if there is a need for like that. It doesn't make sense, but actually means, but in some cases you can do that. Actually means, so you can do a service update for a particular component or subcomponent. And so what we are trying to show here is the current Airship deployment is based on Pike, and so what we are trying to do is actually we're gonna directly jump the Glance API or Glance service in the overcloud from Pike to Rocky, and actually we are using SUSE images for that, and so that's the. So for this actually, so there is a config file which has the version information, and right now, so this is a local config file, because right now we already have a Airship deployment, so there is a version file already there, so I'm not modifying there, so I have a local copy of this, and I modified it so that to avoid the typos and all. But so right now, so like for the Glance, this is the version configuration of version information for those components. So for the Glance API, we are changing. Means in the, we will see it in the demo actually. So by default, it's Pike. So now we're changing to the Rocky OpenSUSE 15 based image, and so for the other components also. But like if you notice here, so I think for heat we are still using whatever is the default, which is Pike in this case. And so yeah, so we just means OpenSUSE based, we are just changing the Glance components, and we are just changing the image for that, and then we're going to copy it to the location basically where the version file is supposed to be there, and then actually yeah, we go through the same interface, update Airship OSH, and so what we're going to so I think now actually we're going to going back to the dashboard and trying to see what version of API, basically what image version right now we have. So right now because we are still going through the deployment, so it's Glance Pike. So basically we are using Pike release of Glance, and so now we will start that. And okay, and the other thing is actually, so when we are making these updates, right? So this is in Kubernetes, actually this is, it's a non-disruptive update. So in the sense that actually the client will not notice that actually there is something changed in the service side. And so to make sure that actually what I'm doing is actually we are doing a Glance API call or Glance CLI call in the loop, and then actually, So this way actually I will make sure that actually what it means Glance is always available. Glance API server is always available. And so this is actually, so we are running this in the loop in one of the terminal. And then also we are going to watch the API pods. And so this is again actually what we are doing is actually we are watching basically. So right now because we have a HA model, so actually we have 2 API pods running. And so soon actually when the site changes are pushed to shipyard, it will start making those changes. So we will see actually now so it's a rolling update scenario. So now actually it got the changes. So the Kubernetes got basically there is a change in the deployment. And so what it's trying to do is actually it's going to stop out of 2, it's going to stop 1 pod and then start creating 2 new pods. So it's going through the initialization of those 2 new pods, and which are based on Rocky image, on the Rocky version. And so it goes through, so basically it's the initialization and all that. And once and then actually when we are doing the pod deployment and it's in the OSH Helm charts, actually we also do some test. So we make sure that actually the service we are deploying is working. So it does some CLI operations. And so it looks like it's already done. So actually, so it's already identified that the 2 new pods which are based on Rocky are already passing the test. So it basically what it does is on the web side, it just transfers the switch from the old pod, which was Pike based, to the Rocky based pods. And so for the customer, actually it's non-disruptive and it's a rolling update. So actually if there is something goes wrong, then actually it won't make the change for the customer, and actually you have an option of going back. And so this is now actually, so it shows actually for the Glance API now we are using Rocky OpenSUSE 15 image. So I think I think this is what we get the benefit of Kubernetes and containers, right? That actually you can make changes based on what means you don't need to make a whole release change, and actually I think
Cool. Does anyone have any questions? This is the end of the demo, but you can see that it's pretty powerful being able to change the parameters, redeploy your cloud, and we're going to use the upgrade facilities to improve the overall upgrade paths in the future, but this is just an indication of what's possible.
I have a question. I get it that it can be done, but I'm still struggling to grasp why would you want to do it as a business. I mean, what exactly do you get with I mean, I get it when you install OpenStack to manage your resources and then install Kubernetes on top of that. Yeah, that makes sense. I mean, why do you go the other way?
Why do you?
Yeah, but I mean, why install OpenStack in containers?
So we get some of these benefits of being able to upgrade seamlessly, because upgrade's always been a big problem actually in OpenStack, and being able to upgrade things while everything's running is a big advantage. The other thing that you get is, we didn't really talk about the idea, but if you lay down a Kubernetes infrastructure and you have a big pool of resources, you could subdivide those resources to run VMs in part of it and native containers in the other part if you wanted to, and share those resources backwards and forwards. So that's another potential benefit. Yes?
So how would you deal with in a case in which you have like an interdependency into modules, like you have Glance and Nova, that they need to be in the same version at the same time?
Mm-hmm.
Or something like this, because in this case it seems easier because you make one. Maybe if there is no minor change, if there is no minor change with the API, it's okay. But if there is any interdependency, I don't know how can you deal with that. Great.
Yeah, I mean, you could answer the Airship part of it. I mean, they have that interdependency built into that. I mean, that's going to be part of our internal processes to work out how we get from point A to point B. right? So we'll have to understand those interdependencies. We do it now when we do upgrades for just bare metal. We have to know what you do in what order.
What I mean is that it wouldn't be as, so you can have, in this case, maybe you can have one working at the latest time, while the other one start working. And in that case, you will need to have two, or then you can have more interdependencies. I don't, well, maybe it's a lot of work in the Airship to put that intelligence, but it won't be as seamless as with one, if you're making only glass.
So I think the idea actually for this demo was actually to show the non-disruptive updates.
Yeah.
Means, but yeah, I mean, you are right, actually means like if you are updating Nova, then actually there might be some dependency on the Neutron. So that's why basically when you define these services, so there is a concept of chart groups. So you want to make sure that actually when you are updating those chart groups or the services within those chart groups, they basically go together. So again, yeah, means again this is just an idea. Means I think, but means yeah, means generally in customer actually environment you may want to do means maybe like, or you can identify means out of 6, 7, 8 services I want to do all these because these are critical services. I will do them together, and for other services which you can, and I think it's provide a story for easy update means. Because, and it's a rolling update, right? So basically if something goes wrong, then actually you can always have an option of going back.
Did you have a comment? Sure.
Well, I wanted to explain that this is just a demo use case, so it doesn't mean that we advertise customers going forward to upgrade it.
Yeah.
But it's just like a use case that demonstrates. It's not saying that we're fundamentally enabling everyone to mix and match all of these services. But you can have dependencies in defined or in the data.
Yeah, actually, I mean you can
define dependencies like you can only deploy this version of the container when you have also this other thing in that version.
Means again in Helm actually you can define actually for Nova basically I need this pod also basically this component from Neutron, so they are deployed together on the same host, and the version is something actually we control in these manifest files in various YAML representation. So
yeah.
Can you explain a little bit? I saw the QEMU compute nodes, but can you explain like KVM, and you mentioned bare metal? Just in my mind, I'm trying to understand how that all works. You know, other hypervisors, and how does that play into it?
So I'll start and you finish. But basically, so KVM is a kernel module, so we're going to be using CaaS version 4 and forward. So we'll be using things that it's just general purpose SLES. So that kernel module can be there, but like
In the micro OS?
No, we're going to be using probably just plain SLES 15, SLES 15 SP1 or 2.
So a customer has to basically build a separate physical server that runs KVM, and then there's a Nova. That's the piece of it.
Yeah, no, the actual worker node would just have the KVM module loaded, so it could run VMs as a regular worker node, as a Kubernetes worker node. And so we're containerizing everything, and including libvirt and everything. So all the componentry that doesn't run in the kernel would be containerized, and that's what we would push out and deploy. And then you would just do normal libvirt. It just happens to be going through a container. And KVM is there, and QEMU and all that stuff. Does that make sense?
Yeah, so the micro OS will have the KVM kernel module.
It's on V4. It's on V4, which is different.
Yeah, V4 has the ability to just use general purpose SLES, and then you apply Kubernetes on top of it, and that's what we're going to be leveraging.
Got it. Okay.
Did you have a question?
Yes, does the storage has to be SES or?
That's just what the tech preview is right now, and we'll have other kind of storage options as well.
Right now, for trying it, you have to deploy SES.
That's what it is right now. I don't know. Is there another option that we're using in the lab?
Simple option like NFS or something just for testing, just for your lab.
I don't know.
Means there are support for NFS also, and then plain Ceph also in upstream. But actually we haven't tested that way. I mean, actually, but yeah, means there is upstream also support NFS, and also I think there is one more actually storage option. I'm forgetting it, but there is a Ceph, and then there is a NFS, and then actually SUSE Enterprise Storage actually what we tested with.
Yeah, so maybe what we'll do is we can talk about it internally, see if there's a simpler setup for storage that we could put in the beta page, if that's something that we've tested somewhere.
Yeah, because for setting up a lab, the requirements for a simple lab will grow a lot. If you have to deploy SES and CaaS.
I think that you guys have got it set up where you can do it in 2 nodes, right? And then you have to have the Ceph cluster externally, but you could actually conceptually do it in VMs, right?
So upstream has a support for NFS provisioner. I mean, I know that actually. So, but we haven't tested that way. I mean, but yeah, I mean, I think if needs to be there, actually, I mean, we can certainly check that also.
Yeah, I'll take a follow-up note to see if we can put something in the beta page, if we can support that. I get your idea. You want to play with it just to see what's going on, and so it's right. And we want your feedback too, so it'd be very valuable for us if it's easier for you to play with it and give us feedback.
So actually, what we have in our dev setup also means we also have a one workstation, and actually we are setting the sets as a VM, and actually we have multiple OSDs, so we have multiple disks configured on the VM. So again, we can still, so we are also running within one workstation. But yeah, I mean, there is definitely SES adds more requirement on the RAM side and hard disk side.
This tech preview, did you say the beta is in a few months?
The tech preview is just going to be linked off the beta page, so it's going to be coming in May. And so we're just using that beta page for Cloud9 to link this tech preview information off of. So that link will, when we have it available, we'll announce it. We'll probably do a blog, and then we'll also have it there on the page. So we'll keep that page alive for Cloud9, the beta, and we'll also point to this tech preview.
All the OpenStack bots are using host network or what existing?
So they are using Kubernetes, but actually means CaaS support flannel. So we are using right now in CaaS 3 actually at least, I think flannel, but I think in CaaS 4, I think I remember it's Cilium.
Yeah.
Cilium, yeah. So yeah, but yeah, I mean they use host network.
But Kubernetes, the problem is you can have only one interface, and on your OpenStack service, I don't know if any of the OpenStack service needs more than one interface. So you handle that case.
I think that's something actually we have to explore more. Actually, that's something we are already looking into it. So somebody in our team is also looking into that area, means how to support multiple type of networks, and so. But I think that's something basically we have to, means I think explore more actually. I mean that, but yeah, that's an open question we have on our side also. Yeah, so yeah. But for compute actually, when there is a plan, means we will have bare metal. So maybe I think somewhere there actually we can, if it is part of CaaS node, then I think we have certain limitation because of that. But for the data network actually we can have. But again, something we have to explore more.
Any more questions? Thank you very much. That was a great demo. Thanks.